Pole, for example, can really only see constellations that are visible north of the equator. They can't see the ones below that because the Earth is in the way. But if you're lucky enough to live near the equator, you can see all the constellations over the course of a year, which brings us to another point. The constellations that you can see don't just depend on where in the world you are. It also matters what time of year you're looking for them. To see why this is, let's take a look at Earth from space. Hey there, home planet. Here's the sun over here, and all those twinkly things are stars and constellations. You'll notice the right side of the Earth is darker than the left side. That's because it's nighttime on that side of the Earth. So people on this side of the planet have a great view of the stars and constellations over here. As the Earth rotates on its axis, whichever part of the planet is facing away from the sun has a great view of these stars during this season. Let's say it's winter if you're in the northern hemisphere and summer if you're in the southern hemisphere. But as you know, the Earth isn't just spinning on its axis, it's also revolving around the sun. So as the Earth moves around the sun, the seasons change from, say, winter to spring, or in the southern hemisphere, summer to fall. And as the seasons change, so do the constellations that are visible at night. So several months later, you're now seeing these stars in this part of space. And as the Earth continues around the sun, the seasons change from spring to summer, or fall to winter in the south. And these stars are now visible to us at night. And finally,
the constellations we see over the equator should not be visible 6 months later anywhere on Earth.
If you're lazy, then you don't really need to concern yourself too much with the whole tilt game. Just focus on how close it is to the horizon. You can work out whether it's southeast or southwest based on how far it is from the horizon. Much like a sunrise, the sun rises in the east as a general rule and sets in the west. Think of Orion as a nighttime sun mimic. That's basically how this works. So now, if we look at this image, as you can see, it's pretty close to the horizon, yet it's almost vertical. From this, one can conclude that this photograph was taken at a very high latitude in the northern hemisphere, probably the top of Norway or somewhere like Iceland, as an example. So that is Orion in a nutshell. We know how it travels across the sky. In high, medium and low latitudes in the northern hemisphere, we know why it travels across the sky with a similar motion to the sun, and we know how to analyse it to find directions. What else can we talk about? Well, let's talk about the ever-changing window for observation. Orion is a seasonal constellation, meaning it will only be visible or partially visible during certain seasons. It's regarded as a winter constellation, because during the winter it completes the full visible cycle from east through south to west. As winter transitions into spring, it only becomes visible in the south and sets in the west. From mid-spring through to summer, it's not visible at all. The constellation becomes visible again in the late autumn, appearing in the east and disappearing into the south, until winter.
That's the same thing Bob the science guy told me and McToon referred to, that you can't see it during the summer. Can't see Orion during the summer. But there's conflicting information all over the place. So here is evidence that Orion is an equatorial constellation. It's over the equator. It can be seen from the southern and northern hemispheres. And like I said, it shouldn't be seen anywhere on Earth 6 months later, because you would be looking into a completely opposite, opposing set of stars, a completely opposite night sky. So I brought this up in debates with McToon, and he just kind of obfuscated and said it works exactly how it's supposed to. And I brought it up when I was debating Bob the science guy, and he's talking all condescending, like, you can't see it in the summer months. Go look out right now when it turns dark. He's like, you need to look into this instead of making claims. So I look into it, and I see that it's visible all throughout the Earth on different spots on the Earth, and he needs to look into it. And this professor coming up in the video is showing his students the shot of the day in June of Orion from a NASA website. So this is more evidence that Orion is in fact an equatorial constellation, meaning you could see it pretty much, it goes over the equator. So when you see it in the night sky, over the equator, 6 months later, we should be looking at a completely different night sky on the entire Earth. So it shouldn't be seen northern or southern hemisphere. It's not like it's pointing toward Polaris or toward the Sigma Octantis or whatever they call it. Also, this is showing what they love to show, their number one proof of the equatorial star time lapse, showing the stars off in the distance, veering off to the left for the southern hemisphere, veering off to the right for the northern hemisphere, and continuing straight over the equator. But that is showing actual deviation, and that's not a fisheye lens. So it shouldn't be showing measurable actual deviation, because that would mean the stars are actually separating, and that would indicate there are 3 separate rotations. And that's supposedly their number one proof, is the 2 polar opposite rotations. But either it's doing that, like it's showing in the equatorial star trail, or it's not, and it's not a proof. And you see these clips here showing different times of the year, in like May, June, July, that it should not be seen anywhere on Earth. It's an equatorial constellation, okay? So it should be seen nowhere on Earth, like Bob said, like these guys in the videos say, and like McToon referred to. This needs to be addressed.
Greetings and welcome to the Introduction to Astronomy. One of the things that I like to do in each of my introductory astronomy classes is to begin the class with the astronomy picture of the day from the NASA website, that is apod.nasa.gov/apod. And today's picture for June the 9th of 2020, well, it is titled Orion over Argentine Mountains. So what do we see here? Well, we are looking at the constellation of Orion up in the sky, and while it may not look exactly like what you're used to seeing, that's because we're looking at a close-up image of it. And in fact, only the central portions of Orion, we can see the 3 stars in the belt towards the center of this image, and in fact, up above towards the top of the belt there, we can see the Horsehead Nebula, and that is a dark,
is rightfully called the Giant Hunter. Orion can be seen from both the northern and southern hemispheres. In the northern hemisphere, the constellation can be seen from late autumn to early spring in the southwest night sky. In the southern hemisphere, Orion can be seen in the summer months, visible inverted in the southwest sky. In both cases, it is seen rising in the east and setting in the west. The best view of this spectacular constellation is said to be observed between latitudes 85 degrees and -75 degrees. It's right